boy Triangle there is looking kind of nervous. He knows I'm closing in on him. Let me show you what I figured out. You start out with the original puzzle. I drew this one out as a true triangle, not as a fake triangle like what they had in the original picture. And as you can see, it still comes out the same way with one extra square in the second example. So even though they did lie and say that all of the parts are the same size, I don't think that's what the problem is. If it was, what we're looking at wouldn't have that missing square still out of it. So now look at this other triangle. This is a different size triangle. This one is 20 by 30. The other one was 5 by 13 or something. Okay, this one works out right. When you swap the two smaller triangles, you still get the same leftover space in each one. So what's the difference in the two? Does it have something to do with those Picasso numbers like I was talking about? I don't know, but I got to wondering what the area of each one of the triangles is, because the amount of squares left over should be whatever the area is minus the two smaller triangles. You follow me? So I figured up the area on both of them. To get the area, you multiply the base times the height and then divide it by 2. So like on A, I multiplied 5 times 13. That's 65, and then divide 65 by 2. It's 32.5. So that's the total area of the whole triangle. Then I did the two smaller triangles inside that triangle. One of them is 2 by 5. 2 times 5 is 10, and 10 divided by 2 is 5. And then the other one is 8 by 3. 8 times 3 is 24, and 24 divided by 2 is 12. So then you add those two together. So that's going to give you the area of the dark green triangle and the red triangle. And that's 17. Then subtract 17 from 32.5, which was what the total area of the entire triangle was. And that leaves off 15.5. So that would be the size that leftover space should be, where you fit the two pieces together, the orange and the light green. Should be 15.5. Okay, on example B, now I think earlier I said it was 20 squares by 30 squares or something like that. That's wrong. It's 10 squares by 20 squares. So 10 times 20 is 200. 200 divided by 2 is 100. And then to figure the two smaller squares in that one, it's 6 times 12, 72. Divided by 2 is 36. And then Maggie is just really being something. Then the other one is 4 times 8 is 32. Divided by 2 is 16. So 36 and 16 is 52. 52 from 100 is 48. Which is exactly what you get in B. You got 48 squares left over in both examples. On A, got something really interesting. I ended up with a half of a square as part of the leftover portion. And that half falls right smack in the middle of what the two answers are, 15 and 16. The answer is 15.5. So maybe it's something about dealing with that extra half, that it rounds it one way when you do it one way and then the other way when you do it the other way. I don't know. I don't think triangles put that much thought into what they do, but it is interesting that it falls right in the middle of the two answers. It's got to be related somehow. Now, I don't think for a second that I'm smarter than this Mr. Tallwalker guy, but I think I can say that in our example that we have, and the one that he started out with, the solution is not that it's a fake triangle. Because you can see right here that it comes out the same with a true triangle as it did in the problem with the fake triangle. And actually, it doesn't matter at all what you do to the hypotenuse, as long as it doesn't change where the two small triangles intersect at. You could have jagged lines going across there or anything, as long as those points, those 2 points where they intersect, remains the same. So I say it has something to do with that half square left over. I don't really know what, and I'm about giving up on ever knowing what it is. But one thing I do know about, the fish in the bucket of water, okay? The bucket of water weighed 10 pounds and the fish weighed 1 pound. So if the fish is swimming around in the water, his weight does not register as long as he is completely suspended in the water and he's not touching the sides or laying on the bottom or anything like that. The bucket will still weigh 10 pounds. If the fish is touching the side of the bucket or laying on the bottom or touching the bucket in any way, his weight will register and the whole thing will weigh 11 pounds. So let me know if any of y'all if y'all had that one figured out or not. And definitely let me know if you got the triangle figured out, because as you can see, I don't. I might see if I can get Mr. Tall Walker to come over here and explain it to us. I might email him or something, see what I get. He'll probably just ignore me, but I can't tell you how many people I've emailed and asked them if I could clip this or that off of their channel. Never once has anybody ever answered me. Maybe I should try harder. Yeah, okay. That wasn't even funny. I'm ready to get off of this whole triangle trip here. I'm going to go see what Diane's been up to. I'm sure she's done something stupid I can talk about. So, y'all be good till next time. Bye.